Imagine a world where humanity is no longer bound by the confines of Earth, where we can explore distant exoplanets, and perhaps even set foot on one. Picture a future where our descendants, or perhaps even us, could travel to distant star systems, like Proxima Centauri, which is home to Proxima B, a planet that has captured the attention of scientists and space enthusiasts alike. The idea of interstellar travel, long considered a far-off dream, might not be as impossible as it seems. Researchers are working tirelessly to develop new propulsion technologies that could one day make journeys to the stars a reality. While we are far from launching manned missions to distant planets, the thought of traveling to exoplanets like Proxima B within our lifetime is beginning to feel within the realm of possibility. So, what are the real challenges, and what breakthroughs are happening in the world of interstellar travel? How realistic are these concepts, and could Proxima B become our stepping stone to the stars? To understand just how far away Proxima B is and how enormous the scale of interstellar travel is, let's first take a look at our current interstellar probes. The Voyager 1 and Voyager 2 missions, launched in the 1970s, have made remarkable progress since their launch, and they continue to travel further and further into space. These probes are not just a testament to human achievement, but they give us a sense of the immense distances involved in traveling through the cosmos. Voyager 1 is currently over 24.6 billion kilometers away from the Sun, while Voyager 2 is about 20.6 billion kilometers away. To put this in perspective, the distance between the Voyager probes and the Sun corresponds to about 165 and 138 astronomical units, respectively, an astronomical unit being the distance from Earth to the Sun, approximately 150 million kilometers. These probes are currently traveling through interstellar space at speeds of around 61,000 kilometers per hour. It might sound fast, but in the vastness of space, it's relatively slow. Now, let's scale this up to the distance to Proxima Centauri, the closest star system to our own. Proxima Centauri, which hosts the exoplanet Proxima B, is just over 4 light-years away. 1 light-year is roughly 9.46 trillion kilometers, meaning Proxima B is over 37 trillion kilometers from Earth. Even the Voyager probes, which are traveling at 61,000 kilometers per hour, would need around 70,000 years to reach Proxima Centauri. And while the Voyager probes are remarkable in their achievements, they're not exactly speed demons by the standards of interstellar travel. The fastest man-made object ever is actually the Parker Solar Probe, which launched in 2018 and has achieved a staggering speed of over 635,000 kilometers per hour. However, even at this breakneck speed, it would still take centuries, to reach Proxima Centauri. This brings us to the challenge of interstellar travel, distance. While we've sent probes into deep space, they are limited by the speed of their propulsion systems and the vast distances between stars. The sheer size of the universe makes it difficult to imagine ever reaching other star systems within a human lifetime. And this is why the idea of traveling to Proxima B, a rocky planet within the habitable zone of its star, has long been considered a science fiction fantasy. But Proxima B is not just any exoplanet, it's one of the most intriguing planets we've discovered so far. Proxima B has captivated the scientific community because it's located in the habitable zone of its host star, Proxima Centauri. The habitable zone is the region around a star where conditions are just right for liquid water to exist, neither too hot nor too cold. This is significant because liquid water is considered one of the key ingredients for life as we know it. Proxima B is about 1.17 times the mass of Earth, and it orbits its star at a distance of only 7 million kilometers, about 5% of the distance between Earth and the Sun. This proximity means that Proxima B only takes about 11 Earth days to complete one orbit around its star, making its year very different from ours. But there's a catch. While Proxima B may lie within the habitable zone of Proxima Centauri, the conditions on the planet might not be as hospitable as we hope. One of the major factors is the possibility that Proxima B is tidally locked, meaning it always shows the same face to its host star. This would result in a harsh division between the planet's day side and night side. One side would be scorched by the intense heat of the star, while the other would be plunged into freezing darkness. However, some models suggest that a small habitable zone could exist in a strip around the planet's terminator line, the boundary between the day and night sides, where temperatures are more moderate and liquid water might exist. But this is still theoretical, and we need much more data to understand whether Proxima B could truly support life. Adding to the complexity, Proxima Centauri is a red dwarf star, known for its frequent and intense flares. These bursts of radiation can be dangerous to any planet in the system, especially one like Proxima B. In 2016, scientists observed an extraordinary flare from Proxima Centauri that was 14,000 times more powerful than any solar flare ever recorded in our own solar system. This radiation could be a serious threat to the atmosphere and potential life on Proxima B. If the flares are strong enough, they could strip away the planet's atmosphere and make it impossible for life to survive. But some researchers believe that Proxima B might still be able to protect itself from these radiation bursts, assuming it has a strong magnetic field to deflect the harmful particles. If Proxima B has such a magnetic field, it could be possible for the planet to retain its atmosphere and maintain liquid water on its surface. Despite the challenges, Proxima B remains a fascinating target for future exploration. But how would humanity ever reach it? As we've seen, our current propulsion systems are woefully inadequate for interstellar travel. The Voyager probes, while impressive, would take tens of thousands of years to reach Proxima Centauri. Even the Parker Solar Probe, which travels at incredible speeds, would take centuries. So how can we make interstellar travel a reality within a human lifetime? This is where the concept of breakthrough propulsion technologies comes into play. One of the most exciting developments in this field is the Breakthrough Starshot project, launched in 2016. This ambitious initiative aims to send small, lightweight spacecraft to Proxima Centauri in just over 20 years. How is this possible? It's all about using light as a propulsion method. The plan is to launch tiny, gram-sized spacecraft, known as starships, equipped with light sails. These sails would be propelled by powerful laser beams from Earth, accelerating them to up to 20% of the speed of light. This concept may sound a bit outlandish, but the science behind it is sound. The idea of using light sails for propulsion was first proposed by physicist Robert Forward in the 1970s. Since then, the idea has been refined, and today, it's a key focus of the Breakthrough Starshot project. The light sails would be propelled by lasers that create a photon pressure, pushing the spacecraft forward at incredible speeds. The goal is to accelerate these tiny spacecraft to 20% of the speed of light, allowing them to reach Proxima Centauri in just over 20 years. However, achieving this goal is not without its challenges. For one, the spacecraft need to be incredibly lightweight. To survive the intense acceleration from the lasers, potentially thousands of times the force of gravity, the spacecraft would need to be made of extremely lightweight and durable materials, such as graphene. The spacecraft would also need to be equipped with a small computer, a camera, and a communication system, making them incredibly compact. But there's more. The lasers required to propel the spacecraft would need to be incredibly powerful. A large array of lasers, combining to form a 100 gigawatt beam, would be necessary to create the force needed to accelerate the spacecraft to 20% of the speed of light. But even after the spacecraft is accelerated to this incredible speed, there's still the issue of deceleration. Once the spacecraft approaches the Proxima Centauri system, it would need to slow down to avoid overshooting its target. This is where a fascinating concept comes into play, using the gravitational fields of nearby stars to decelerate the spacecraft. By adjusting the orientation of its light sail, the spacecraft could use the gravity of the stars in the Proxima Centauri system to slow down. This technique, known as a gravity assist, could help the spacecraft enter orbit around Proxima B, or at least get close enough to gather valuable data about the planet. The challenges are immense, but so are the potential rewards. The technology required to make Breakthrough Starshot a reality is still in development, but the project has already made significant strides. If successful, it would mark the first ever interstellar mission, and Proxima B would be just the first stop. The ultimate goal is to explore not just Proxima Centauri, but other nearby star systems as well. the implications of this technology are enormous, and it could open up a new era of exploration, allowing humanity to venture into the stars as we've always dreamed. While we're still a long way from launching a mission to Proxima B, the very fact that we're considering it is a huge step forward. The science and technology that would enable interstellar travel are advancing, and who knows, perhaps one day, we'll have the tools to send humans to Proxima B or even beyond. Whether or not Proxima B becomes our interstellar springboard, it's clear that the dream of exploring other worlds is becoming more achievable with every passing year. So, buckle up, the future of space exploration is on the horizon, and it's brighter than ever before.